Okay, so we continue where we ended. Okay, so let me start from here, just to emphasize some points. So we are saying these are characteristics of triggers. So these are the further categories of triggers, depending on what action is being performed. Okay, so we have insert triggers. These are activated or fired whenever there is an attempt to insert a new row in a table. In the trigger table, that is the table to which the trigger is assigned. The newly inserted rows are added to the inserted table only. Delete trigger is fired whenever an attempt is made to delete rows from the trigger table. That is the table to which a trigger has been assigned. The deleted rows are added to the deleted table. The deleted and trigger table do not have any common rows, as is the case for the inserted table and triggered table, which I was trying to explain. Update trigger is fired when an update statement is executed in the trigger table. The update trigger uses two logical tables for its operation. The delete table uses only one table, one logical table. The insert trigger also uses only one table. But the trigger update trigger uses both logical tables, the deleted table and the inserted table. Again, let me just go over this because I feel it's very important to understand this. What we're saying is if we have a table, okay, I'll just switch to Excel. If we have a table for orders like this one, and we decide to update this number, the quantity, to say 4, what is going to happen is that SQL Server is first, before making the changes, it's going to record what is in the table. And that's a table which is called inserted table. Once the update has been done, this is now 4. Sorry, I keep confusing this. It's the deleted table. So this is the original data. Once the update has been made, the data has been updated, then this is now going to become, this will also be copied to the inserted table. In other words, the information currently there in the table and in this table, inserted table, are going to be identical. If we are deleting maybe we want to delete this row. What is going to happen is that this will be taken away from there and it's going to be placed there. So the delete trigger is not going to make use of the inserted table. The delete trigger will only make use of this logical table. These two are the logical tables I'm talking about. So these are the two logical tables I'm talking about, or the magical tables.
Okay.
Okay. When we are deleting, with SQL Server is just going to remove the row from there and place it in this table. It's going to make only use of this table, but the information is going to be removed from the original or the trigger table and placed in there. If we are using an update, it's different. It's going to take the information before updating, place it in the deleted table, then update this information. Then after updating this information, then it's going to take the new row and place it in the inserted table. So the update trigger is going to make use of both of these logical or magical tables. Insert trigger, on the other hand, is going to just add a new row there. And once it has done that, it's going to also copy the same information which has been added to this table and place it in the inserted table. So here, there will be rows which are going to be identical to what the rows in this table. It will only make use of this logical table. So it's only the update trigger which is going to make use of both of the logical tables. Are we together?
Yes, sir.
Okay. Now, there are three ways of implementing differential integrity by using delete triggers. The first one is called cascade method. The second is restrict method. The third is nullify method. Cascade method deletes the corresponding records from the dependent tables whenever a record is deleted from the master table. Restrict method restricts the deletion of the record from the master table if the related records are present in the dependent tables. Nullify method nullifies the value in the specified columns of the dependent tables whenever a record is deleted from the master table. What I mean is this. Assume that we have created this table. Okay, let's go ahead. Maybe for lack of time, I'll come and create it next time. But if we were to create, use an inner joint to retrieve information from these two tables and display it together, we may want to have, say, okay, all these. And we might also want to have the date and quantity. Okay, so we're going to have, say, for the first order, this one, we're going to have the product ID is going to be 102.
Okay.
And that's the date. And 102 is there. So that's there. Then for the next one, we are going to have again 102. So all that will be there. And this information. For the third one, we are going to have 101. So we're going to have that. And we're going to have that. And for the last one, we are going to have 102. So again, here we're going to have 102, and we're going to have HP, and that's going to be, sorry, not HP, this 102 is Lenovo, and that's going to be that. And that's the date and the quantity. So this is, if we use an inner joint, we can retrieve this information and we get these results. Now, what we're saying is, when there is a delete trigger on this table,
Yes.
there are three approaches. One is this one. The one is cascade method. The second is restrict method, and the last one is verify method. Now, if we go with the cascade method, what is going to happen is that if this is deleted in this table, then it's also going to delete wherever in this other table, wherever 101 appears, that is going to be deleted. Or if it's this one that is deleted, then everywhere where there is 102 will be deleted like that. That's the cascading effect. It will go to all the related tables and delete the corresponding rows.
That's good.
That's the first one. The next one is the restrict trigger, restrict method. Restrict method is going to say, before deleting this record, there shouldn't be a 102 anywhere. So if there is 102 there, then it will not delete. You'll get an error message. And that's the default. So this one will not be deleted, this one will not be deleted, and that one will not be deleted. But if we start by deleting these, we delete that, and delete that, then we can come to this one and delete this one. Then it will accept.
Okay, sir, can I ask you a question?
Yes, yes.
Here you mean that yes, you have to delete first from the child table before you delete from the parent table?
Yes, yes.
Okay, I get it.
Okay. The last one is where the NIIT method. What is going to happen that where there is 102, it's going to put now. So that in this, what we are going to have is there, it will be showing now if we are to retrieve that. So these are the three approaches to the delete trigger. Okay. Depending on the way the triggers are fired, they can also be categorized further as after trigger or instead of trigger. This one, instead of trigger. After triggers can be created on any table to insert, update, or delete operation, just like other triggers. So we are saying the after triggers can be created on any table for inserting, updating, and delete operations. They are fired after the execution of the data manipulation language operation for which they have been defined. So if it's a delete trigger, which is an after trigger, whenever you delete something for that table, then this trigger is going to be executed. If more than one after trigger is created on a table, they are executed in the order of creation. This is important. The triggers, the after triggers, let me go to the last one, then I emphasize the third point. You can have multiple after triggers for a single data manipulation operation. So now the third point I need to emphasize is, if this table, you have defined maybe 2 after triggers, the first trigger to be created is going to be fired first, executed first. Then the second trigger is going to be executed next.
Okay.
If you have 4 triggers, after triggers for a given table, then they are going to be executed in that sequence, starting from the first one, then the second, third, and then lastly the fourth.
Okay.
The last point is saying you can have, for the same operation, say delete or update table, you can define one or more after triggers.
Okay.
So the same operation of updating rows in a given members table can result in multiple after triggers being executed, affecting maybe different other tables. Now, I'm emphasizing this because this is something that differentiates it from the next type that we're going to look at, which is the instead of. Instead of triggers can be primarily used to perform an action such as data manipulation operation on another table or view. Can be created on both a table and a view. These are suitable for the following cases. When you need to ignore part of a batch, we looked at batches. When you have a batch and the user tries to execute a batch, in that batch, there might be some statements which should not be executed. So those statements, if they're not executed, they're going to result in an error. So what you can do is you can use a trigger, and instead of trigger, so that when SQL Server says that, oh, you want to do this action, it will do something else instead. That's why they're called instead of trigger.
Okay.
These are suitable for not processing a part of a batch or for logging problem rows.
Okay.
So when you don't want to process a part of a batch or some statements in a batch, but instead you want to write them in a log file for future use or for auditing, then you can use instead of trigger. So for example, a user is accessing a table for which they do not have permissions to alter the information, to update the rows. When they attempt to alter the information will not be altered. Instead, that action, that attempt is going to be recorded in the log file.
Okay.
Instead of trigger can be used to restrict deletion in a master table, e.g. displaying a message. Master record cannot be deleted if a delete statement is executed on the master table. So where you want users not to be able to delete information from the main table, you can use the instead of trigger, so that whenever a user tries to issue the delete statement, the SQL Server is not going to delete. Instead, it's going to display this error message.
Okay.
You cannot create more than one instead of trigger for a DML operation in the same table of view. That's why I was emphasizing this point. For after triggers, you can have multiple triggers for the same DML operation, like delete, update, delete, update, or delete, update, delete, update, or insert. Okay. You can have like an insert statement operation. You can define more than one after trigger. But for the instead of trigger, you cannot have more than one trigger for each insert operation.
Okay.
I don't know if I've made that point clear. It's important that you understand that. Because if you
Yes,
attempt, you are
it's
going
clear.
to have some problems, or you can get a question like this in an exam. Okay. Now, so far we have only looked at data manipulation language triggers. The second category or main group of triggers is data definition language triggers. DDL triggers are fired instead of data definition language statements such as create table or alter table. Okay. They can be used to perform administrative tasks such as database auditing. Database auditing is a process where user activities are performed quite okay, but they are also recorded. So that, for example, it's a university database where there are results of students, and you have an opportunity, someone comes to you say, you work in IT, can you go and manipulate my results site where I got a C, I get an A, and I'll give you 10,000. If you do that, the system, even if it's maybe 3 months later or a year later, should be able to come and show that on this particular date and time, you logged in and did this. You changed permissions of a user, or you modified the table, or you created a table on such and such a day and time. That is auditing.
Okay.
So auditing is recording events as they occur, the date, the person who is doing the action, as well as maybe the objects which are affected. And this can be used as evidence in court cases or for disciplinary actions in an organization.
Okay.
DDL operations can include operations such as creation of a table or a view, or modification of a table or a procedure. All these are examples of data definition language operations.
Okay.
Now, triggers can be nested, like we mentioned. Okay, nested triggers are fired due to the action of other triggers. Both data manipulation language triggers and data definition language triggers can be nested when a trigger performs an action that initiates another trigger. For example, a delete trigger on a department table deletes the corresponding employee records in the employee table, and a delete trigger on the employee table inserts those deleted employees' records into the employee history table. So here I'm supposed to indicate insert, not rows inserted, not deleted. Okay. So we have the trigger on this table, a delete trigger, being fired on this one. So it will go to also this table, department is deleted. Then the trigger also deletes the details in the employee table, and that information is moved into the employee history table. So we have this trigger resulting in this other trigger being executed. So this is a nested, these are nested triggers.
Yes, okay.
The other type of triggers are called recursive triggers. Recursive triggers are a special case of nested triggers. Unlike nested triggers, the support for the recursive triggers is at the database level. What I mean is the triggers are defined at the database level. The nested triggers that we have looked at previously are defined on a table.
Okay.
A recursive trigger is one that calls itself. In other words, a trigger is when the trigger is executing, it will trigger itself in the process. So it forms like a loop. Okay. So there will be some mechanism for them to stop. But what we're saying is that a recursive trigger is where the loop initiates, sorry, the trigger initiates its own self. Okay. Now there are two types of recursive triggers. There are direct recursive triggers and indirect recursive triggers.
Okay.
The direct recursive triggers, when a trigger fires and performs an action that causes the same trigger to fire again. In other words, you have defined a trigger here to be fired when there is an update on a table. So when you update a row on this table A, this trigger is going to be executed, and in the process, this trigger is going to make some changes to this same table. And because it has made changes to this table, it will activate itself again. So it forms like a loop. The difference is that it's only one trigger which is involved. It's performing actions which are activating itself. That's a direct recursive trigger.
Okay.
The second type is the indirect recursive trigger. This one, a trigger that fires another trigger on another table, and eventually the nested trigger ends up firing the first trigger again. E.g., update statement on table A fires a trigger to update table B, and this executes another trigger to update table C, but table C also results in execution of a trigger which is going to update table A. And because table A has been updated, this trigger again is going to be executed. So it forms a loop. This is slightly different from the first one in the sense that it's not the it's not the same trigger activating itself, but there is a set of triggers which are doing things which result in the first trigger being triggered or activated again. That's the difference. Okay, that's the end of my presentation. Are there any questions? Any questions?
On the same triggers, sir.
Yes.
I want to know these same triggers, like, yes, for example, someone tries to make changes in your database.
Yes.
So these triggers will prevent that changes to happen by is by what, displaying a message or sending a message. If it is sending a message, where does the message go?
What we are saying is that if I'm assuming that you're referring to the instead of trigger.
Yes.
Okay. So we're saying if it's the instead of trigger, the trigger is not going to perform the requested action. Instead, a message will be displayed.
Okay.
Yes.
So, like, if you, the what administrator can,
Yes.
like, you can drop those triggers and perform the action that you want to do with the tables.
Yes,
or the
you
database. Okay. So they are for protecting data, in short.
Yes, that's why we said they are there to ensure data integrity. So that when the changes are made to data, it should be in the proper way.
Okay.
That's for data manipulation triggers. Data definition language triggers can be used for auditing. They can, for example, prevent, but they can also record, perform the action, but also record it. So that if there is an inquiry to say, who did this on the database, who deleted this table, they can go to the system and check and find that information.
Okay.
Yes.
All right.
Any other question? I have about a minute before my time runs out. And like I said, this is just the first part. Yes, yes, Cozy.
When executing triggers, do you have to refer to the parent table or the child table, or it's either one?
Sorry, come again?
When executing triggers, do you have to refer to the parent table or the child table?
The triggers are associated with a given table. That's the trigger table. It doesn't matter whether it's a parent table where there's a primary key or not.
Okay.
Yes. So the action you define will depend on, will be viewed from the perspective